Okay, so in today's video, we'll be discussing Unit 2.14 of the Math AAHL course, which is odd and even functions. Now, we'll start by defining what both of these terms mean. And an odd function is basically when when f of minus x equals minus f of x. And I'll get to what that means in a second. But an even function, on the other hand, is when f of x equals f of minus x. Okay. And for odd functions, let's say we have this function here where f of x equals x cubed minus or plus x. Okay, so if we have f of minus x, the function of minus x, this would be minus x cubed plus minus x, right? And minus x cubed is minus x cubed, sign doesn't change. Plus minus x, sign changes to minus, and now we have this function here. And if we factorize out the minus, we'll have this, right? So you can bring in the minus, it becomes minus x cubed minus x, which is this. And what you'll notice is that this here is the same as this here, right? So you have function of minus x is equal to minus function of x, right? This here equals to minus this. So that's an odd function. That's what they look like. And an even function is, let's say we have f of x equals x squared plus 1. A very simple function of minus x is minus x squared plus 1. Since it's squared, the sign will change to positive. And now you just have this here is the same as this here. So function of x equals to function of minus x. And for a function to be even or odd, obviously these two, one of them has to be fulfilled, but not every function will be an odd or even function. Only a rare specific amount of functions are odd and even. So some of them or most functions are neither odd or even. So don't think that every function is either odd or even. Most of them aren't. Okay. And some things that all odd and even functions have in common is that when you graph them, an odd function will always be symmetrical along the x-axis. So if you take this side here and you bring it down, it's going to be symmetrical to this, right? And the same thing with even functions, but along the y-axis instead. So if you have this here and you bring it over, it's going to be symmetrical. Okay, so these are your odd and even functions. Next, we have domain restrictions. So let's say we had this function here, f of x equals x minus 3 squared plus 1. So a nice little quadratic function in vertex form, right? And now we want to get the inverse of this function. And we know that to get an inverse function, you just change the place of the x and the y, and you isolate the y, sorry. So you have x equals y minus 3 squared plus 1. First, move the plus 1 across, so x minus 1 equals y minus 3 squared. And now we root both sides. So we have root x minus 1 equals y minus 3. But this root x minus 1 here can either be positive or negative, right? Because it's either minus x minus 1 squared will become y minus 3. And then we just move the minus 3 across, and we have inverse function is 3 plus or minus root x minus 1, right? Thing is, for something to be equal to function, each input can only have one output. But since this is plus or minus here, it has two outputs. And to illustrate what this means, if we draw the graph of this function here, right? If we draw the graph, it will look something like this, right? Where if you do a vertical line test, you draw a line across, it will touch the graph twice. And if that happens, this means it's not a function. So how can we make this into a function? Well, it's pretty simple. We can either just erase this entire part or erase this entire part, right? And how do we do that, you may ask? Well, it's actually pretty simple, and it's something called domain restrictions. So if we remove the inverse, and if we put normal function, since it's in vertex form, we know that x equals 3, y equals 1. That's the coordinates of the vertex. So x equals 3, y equals 1. That's the vertex here. And just move the whole thing down a bit. If we draw the function, it will look like this, right? Now, what we can do is we draw a line across the turning point, and we want either this side of the function or this side of the function. Basically, we want to make the function a one-on-one. So each y has only one x, and each x has only one y. So we either want this side of the function or this side of the function. And how do we do that? We just restrict the domain. So if we wanted this side here, we say the function from minus infinity to x to 3, right? And this side would be 3 to x to infinity. So here, any x value between 3 and infinity. So 3, 4, 5, 6, blah, 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 blah. And here, any x value between minus infinity to 3. So all of this here. And what we also know is that the domain of f of x is the range of the inverse, right? So let's say that we have this function here and we restricted the domain to this. So this is our domain now. When we have this inverse function, the range of this function will be from negative infinity to y to 3, right? Because if it's the domain here, then it's the range here. And now let's say we wanted the function of any number. Let's say the inverse function of 2. Inverse function of 2 would give you 3 plus or minus root 2 minus 1, which would be 3 plus or minus root 1, which is just 1. So it'll give you either 4 or 2, right? But now we have that the domain is between minus infinity and 3. Sorry, the range is between minus infinity and 3. So this 4 here, we can just cross it out. This 4 is gone, right? This 4 is gone. And we're left with 2. So if we graph this function now, if we graph the inverse, it's gonna look like, it will look something like this, right? Where the top part is just gone now. We don't have this top part anymore. We have a function. And to generalize domain restriction, so now we did this for quadratics, right? Quadratics, we said we just put a line across the vertex, the turning point. But if you had a function which was like, I don't know, let's say something like this, right? Let's make it something like this. Okay, what you can do is just draw a line across every turning point. So there's one here, there's one here, and there's one here. And you can choose where to restrict the domain. You can either do from here to negative infinity, from here to here, from here to here, from here to here, or from here to infinity. It doesn't really matter where you restrict the domain as long as you make it a one-on-one function. But if it doesn't specify where you have to restrict it, you can just choose any two turning points and take the area between them, right? So this is domain restriction. Okay, so we'll finish off this video with a nice little past paper question. So this is a paper 2 question, which means you are allowed to use a calculator. So for part B, just kind of just plug in the equation into the calculator and you'll just copy it. But basically what you get is that you have asymptotes at x cannot be minus 1 and x cannot be 1. I don't really need a calculator to find this out, but yeah, you don't really need to work anything out. And the graph crosses the x-axis, or yeah, the x-axis at 2.900 and negative 2.900. And again, you can just get this by putting it into the calculator, nothing much. But yeah, pretty simple. Anyways, part C, explain why this is an even function. Now, to get the mark, all you have to say is that f of x equals f of minus x. If you write this down, you'll get the mark. But just in case, it's nice to show you're working out. And you do this by just saying f of minus x equals minus 1 plus ln root minus x squared minus 1, right? And this is minus 1. Let's do the same thing. Minus x squared would just be x squared minus 1. And since this is the same as this, hence f of x equals f of minus x. Now part D, again, all you need to write, all that's in the mark scheme, is that does not pass vertical line test. Okay, that's all you have to do to get the mark. But again, I'll show my working out just so that it becomes more clear. So first we just want to find the inverse function. And to find the inverse, we switch the x and the y, right? So you'll have x equals minus 1 plus ln root y squared minus 1. First you bring the 1 across, you have x plus 1 equals ln root y squared minus 1. And you know that to get rid of the ln, you just do e to the power of x plus 1 equals root y squared minus 1 using your unit 1 logarithm rules. And now we just square both sides, so you have e to the power of 2x plus 2. Again, more exponential rules equals y squared minus 1. Bring the 1 across, you have e to the power of 2x plus 2 plus 1 equals y squared. And now you square root both sides, and you have the inverse function is plus or minus square root of e to the power of 2x plus 2 plus 1, right? So you have this plus or minus here, meaning two solutions, hence there's no inverse function. Okay, pretty simple. And now we get to the last part where the function g is defined by this, and now they give you a domain restriction. And since the domain is restricted to 1 to infinity, so if you go back to the original function here, the domain is restricted to this, meaning that we can just take all of this out, right? This is our function now. Find the inverse function and state its domain. So we just found the inverse function here, right? Just found the inverse function. Its domain now would be, the range of the original function, right? So the range of f of x is the domain of the inverse. And since the range of this function, it goes all the way from negative infinity all the way up to infinity, so for 8d, or 8e, sorry, the domain of this function now is negative infinity to x to infinity, or x is just all real numbers. X is all real numbers, right? Pretty simple.